What if an airplane just kept going up? Higher, and higher, and higher, until it reached space. It sounds possible at first. After all, airplanes already fly miles above the Earth. Some military jets fly even higher. So why can't a normal airplane, or even the fastest airplane ever built, simply keep climbing until it reaches space? The answer is surprisingly simple, because the higher a plane goes, the less the sky helps it fly. And at some point, there's just not enough air left for an airplane to work at all. To understand why, we first need to understand something important: airplanes do not fly like rockets. A rocket carries its own fuel and oxygen, and it creates massive thrust to force itself upward, even in the vacuum of space. But an airplane is completely different. An airplane depends on the atmosphere. It needs air for two main reasons. First, air flowing over the wings creates lift. Second, most airplane engines need oxygen from the atmosphere to burn fuel and produce thrust. So the moment air starts getting thinner, an airplane starts losing the two things it needs most: lift and engine power. That's where the problem begins. At normal cruising altitude, which is usually around 30,000 to 40,000 feet, passenger planes are already flying in very thin air compared to the ground. That thinner air is actually useful. It reduces drag, which helps planes fly more efficiently and burn less fuel. But there's a limit. As a plane climbs higher, the air becomes so thin that the wings have to work harder to generate lift. To compensate, the plane needs to fly faster. But there's a catch. As the plane speeds up at high altitude, it gets closer to its critical speed limit. So now the aircraft is trapped between two dangers. If it flies too slow, it stalls because the wings can't generate enough lift. If it flies too fast, it risks structural stress or loss of control. Pilots call this narrow margin the coffin corner. And that alone already shows why planes can't just keep climbing forever. But it gets worse. Jet engines also need air. A jet engine works by sucking in huge amounts of air, compressing it, mixing it with fuel, and igniting it. That hot expanding gas shoots backward and pushes the airplane forward. No air means no proper combustion. And if there isn't enough oxygen, the engine simply can't generate enough thrust. So even if the wings could somehow keep working, the engines would eventually stop being effective. And once you go high enough, the atmosphere becomes so thin that a jet engine becomes nearly useless. This is where many people imagine a simple solution: what about making the plane more powerful? What if we built a super airplane with giant engines and huge wings? Would that let it reach space? Not really, because the problem is not just power. It's the entire design of an airplane. Airplanes are built for the atmosphere. Their wings, engines, and control surfaces all depend on moving through air. In space, there is essentially no air. That means wings produce no lift. Engines that rely on oxygen stop working. And even control surfaces like rudders and elevators become useless, because there's no airflow to push against. In other words, in space, an airplane stops being an airplane. It becomes a dead shape moving without the environment it was designed for. Now here's where it gets even more interesting. Space does not actually begin at some dramatic visible barrier in the sky. There is no giant line you can see from a cockpit, but the commonly accepted boundary of space is called the Kármán line, around 100 kilometers above Earth. That's about 328,000 feet. Compare that to a normal airliner flying at around 35,000 feet. That means space begins nearly 10 times higher than where most passenger planes cruise. And airplanes are nowhere near capable of operating that high. Even the highest flying aircraft in history didn't come close to truly flying in space like a rocket. Some experimental aircraft, like the X-15, reached the edge of space. But there's a huge detail: it wasn't a normal airplane. It was more like a rocket-powered experimental aircraft launched from another plane. And once it got that high, it wasn't flying like a normal airliner at all. It was operating in a completely different regime. So when people ask, why can't airplanes fly into space? The real answer is this, because airplanes are machines built to ride on air. And space has almost no air to ride on. No lift. No breathable oxygen for jet engines. No useful control surfaces. No atmospheric support. The airplane would run out of the very thing that makes flight possible. So while rockets fight their way into space by carrying everything they need with them, airplanes are prisoners of the sky. They can climb high. They can cross oceans. They can fly at incredible speeds. But eventually, every airplane reaches the same invisible wall. The point where the atmosphere becomes too thin to hold it up. And beyond that point, only rockets can go. So the next time you look out of an airplane window and see the sky turning dark blue above the clouds, just remember, that plane is already near the edge of its world. And above that world is a place where wings no longer matter. If you enjoyed this video, subscribe for more aviation mysteries and hidden facts.